You know, there's something I think many people would do well to understand, and I'm not going to sugarcoat it. Life is pain. Life is combat. Life is the spoils go to the victor at the end of the day, and the story is told by the winner. If I have the bigger stick, I also have the, what do you call the that thing that, you know, you're at like a protest and you go, we will not, you know, that thing, you know, the louds, there's a word for that you put over your mouth, and it makes you the guy who, I have the conch. Today we're going to do some programming in x86 assembly. It's going to be some of the best you've ever seen. It's going to be some of the most beautiful programming. It's going to be everything that you're aware of, at least, and it's going to make you feel like you're just a boy again. So, starting in on some programming, I think it's important to caveat this by saying I need to pull everything from GitHub. Git pull origin master. If you are just joining us, because I know we've got a lot of new viewers in today, if you're just joining us, we are currently working on a renderer. Look at that beautiful renderer. That's an old version. We are going to make it, and then we're going to run it. And we are exiting immediately, because I believe last time I was programming this renderer, I was doing a sort of what a dumb thing to do. A dumb fuck thing to do. But it is what I'm going to do. Fuck off. Okay, fuck, what? Okay, so anyway, we've got our original, this is our original code base. It was quite large. If you want to see what the state of this programming project was just moments ago, you can go to my YouTube channel, youtube.com/@CSMalason. And this is what you will find. You will find straightforwardly, some reflection, cubes reflecting off of each other. A little bit of fuzziness. You might not be able to see that, but it is a little fuzzy. And they're just having a good time. You know, am I 100% sure that this is a correct reflection? No. No, I'm not. But we're gonna be sure, because we're reprogramming the damn thing. The reason I wanted to reprogram the thing was mostly just because I felt like, you know, the logic was just getting a little bit too hard to follow, and I think I was learning assembly at the same time as writing this program, and so now that I have a little bit more under my belt, I will maybe be able to see, oh, well, that was just a weird thing to do, you know, type of thing back there. I'm going to turn my microphone down. It's like clipping. And then I'm going to go back to OBS and see what my situation is like. You lost me for a moment there. We're adding some gain. We're going to add some gain. Some Gloria Gaynor, you know? I think we all know what I'm talking about. We're going to add even more gain. It's probably almost getting a little intense now. You're starting to feel a little weak. You're starting to feel a little bit weak in the knees. So what I'm going to do now is I'm going to just, to make sure, I'm going to put a limiter on there with a threshold of, let's go -3. Let's go a little spicy, you know, a little spicy. Let's do 5. Let's do -4 as our limiting value. It seems like I can get up to that a bit more easily than maybe I would like to. So I'm going to switch this down to 6.5. Nah, I just did 6, I think. 6, that's fine. You know, I'll go with it. I'll go with 6. I'm yelling into the microphone! Seems like we're fine. All right, so now it's time to do more programming. Anyway, things were getting just a little bit. I hope that I can make things a little bit more. I think readable. So one thing that I do want to do is I want to, if I can actually, I'd like to just. I guess these aren't aligned in that way, so never mind. Okay, I would like to put the original on the left and the new on the right. And I would like to see where I'm at. So I've initialized GLFW, I've done OpenGL and stuff, compiled shaders, etc., etc. And then we're exiting. And so what we want to do is now we want to get into thread management. Last time I never ended up creating sort of a thread local storage space or a thread stack or anything like that. I think what I'm going to do is I'm going to try to make more use of kind of the, I'm using flat assembler, and I'm going to make more use of the macros that are available to me, because I think it will be important to do things like, I just think it will be nice. I was a little bit like I'll raw dog it when I first started this this project, and now I'm thinking maybe I won't raw dog it too much. So okay, so we're gonna do threads. So we are going to say, and there will be a thread count symbol here that we'll define. I think I defined all these at the bottom in the data section, but I think instead I'm going to define them up here so that there's kind of a real mental separation between the two things. Thread count equals, let's just say 1 for now. We'll get there. And I'm just going to say EQ. No, I'm going to do equals. EQ I will only use for the floating point numbers like I was doing before. And then I'll say, we will put this right here. Threads, if thread count is greater than 1, and if I've got weird noise coming from my thing. Okay, so we've got if thread count equals 1, then we'll repeat for thread count number of times. -1. Interesting. Does that make sense? Thread count, repeat thread count number of times. Yeah, that's interesting. You'd want to do... Oh, no, yeah, -1. Yeah, because you're spawning a number of child threads. Like, the host is also a thread, so you're spawning child threads here. So we're moving RAX. I don't really know if that's... Yeah, we'll do that. Okay, RAX 56th. Move. Actually, I'm just going to copy this code. I don't see any reason not to just copy it. Thread. Let's just copy the code and see if we want to do anything to it. So let's take a little read through. So if thread count is greater than 1, we will repeat thread count for thread count -1. We're on 37, which we I suppose want to be. Yep, sure. Wow, I did a column 37 for these, which is interesting. I guess that's because it's a column offset, and I probably maybe put these things in before that time or something like that. I don't know. It's interesting. Yeah, this is also on 34 for some reason. Wait, why? Oh, I see. Yeah. Yeah. Well, let's indent this back this way. Yeah, that makes sense. Also, do I want to indent the actual that? Oh, that's tough. I think I will. I'll indent it. It's tough to figure out what the right indenting rules ought to be. Some people actually indent things logically. Like if they're doing like the equivalent of a while loop, then they'll actually indent the while loop, the logic that is in the while loop. But that just seems to me like just program C at that point. You guys know what I mean? Just program C program. I think my laptop battery will do fine. I'm using my laptop to monitor the stream and whatnot. Let's get something more cool up on our other fucking on our fucking Firefox. Yeah, let's get one of these. Like you'll be like, oh, intersection code, type of thing. Okay, so we're doing this RAX56 RDI clone flags, and we have clone flags defined up there. RSI pixels. This is not what we want. What we want is an actual. So this is child stack pointer, and I don't really know. It's like, okay, sys clone child stack pointer versus thread local storage. Like I'm not really sure what thread local storage truly is. Yeah, Linux storage thread and stack. System call clone. First parameter generate blah 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 function child stack space of the generated child process. The flags parameter is very critical. It is this parameter that distinguishes how the generated child process and parent process share resources. Okay, this seems formatted incorrectly, but anyway. Okay, effects of clone parameter. Yeah. Thread and clone. Threads and stacks. View the 8 megabyte stack size during thread creation. In fact, 4K more space will be allocated. Oh. Let's take a closer look. Thread and Guard thread stack is a rather strange product. On the other hand, the thread stack is unique to the thread, and it stores thread running status, local variables, function calls, and other information. On the other hand, from the perspective of resource management, the stacks of all threads belong to the same memory process. Threads in the parent process share resources. Other threads in the process can actually modify the stack memory thread. Sure. It creates 2 threads. Copies the address of the buffer rate to the global pointer. Are they just demonstrating that it's the same? Yeah. Oh, in order to reduce the impact of stack cross-border, the operating system introduced the concept of stack guard, which is to allocate one page or multiple pages of memory to each thread stack. This memory is unreadable, unwritable, and unexecutable as long as access will cause a seg fault. Interesting. So they're just saying that there's like a 4K, like a memory, like a single page that gets allocated at the end of a child thread stack that then will cause like a seg fault or whatever. Why is that on top of my? Oh, my screen's what? I'm looking at this and it looks like I have a screen thing on my stream. Let me look at that real quick. Where's my window capture? Okay. Let's see if it goes away when I go back. Should be. Yeah. Weird. Okay. Anyway. All right. So default size of stack is 8 megabath. So I also think this is not having to do with the straight up like syscall to clone that I'm doing. I don't think so because I don't think that the clone syscall allocates any memory. Maybe it does. I should maybe read this more carefully. But as far as I can tell, you need to pass in an actual buffer that you allocated or whatever into the stack pointer. But okay, but let's just do this. What we're going to do is this. So I think we should have a struct. I need to know how to do that because it is not necessarily trivial how to do that. Do I want it to be in the... It should just be... Let's put it in the zero initialized memory. And let's call it struct. Let's put... since this is a macro thing, let's just put it up here, I think, yeah. and struct, and it'll be called thread memory. And then it'll be like here, FASM struct. FASM struct. We want the manual. We want structures. Okay, so .xdw. Okay, gotcha. Okay, so it's just a label like anything else, but it is then like namespaced within that thread memory thing or whatever. We'll figure out how this works. Okay, so it's going to be, well, firstly, I mean, what are the things? Obviously, we need a number of things. Let's pop some of them in there, and we'll think about it later. The one thing I want to just make sure to do this time is to sort of not use explicit offsets into things. At least, you know, not outside the context of like a very small like function or something that just like, you know, adds stack space. But we're not going to be like doing real function calls with like a stack pointer, the stack pointer changing and stuff, like the base pointer, during any of the hot loops. So that's not really relevant to this thread memory for the most part. So we will think about what we actually need here. So the thread has some of these things, which we were initially putting into registers, but let's put into the thread memory. And let's put everything into the thread memory. And we will then just like put it into right before the hot loop. It depends on what we mean by the hot loop. I mean, I think every pixel is a hot loop. Maybe not every pixel. Like, you know, we can probably do some things like pre-put some data into some registers from memory. But, you know, as long as we're reasonably careful about how we do that, we can probably do that every pixel. Once you get down to, like, every sample, that's definitely a hot loop. Certainly once you get down to every bounce, that is, like, hopefully we can get everything into, like, registers. Like, just everything into registers for those loops. But we'll see. But the thing is, like, that this memory, doing the memory like this will allow us to create that hierarchy much more explicitly. Whereas before, we really needed to use registers to keep certain things that, like, aren't that important to keep around. Like, especially the XMM registers is really what I'm thinking of. Like, what did we have? Like, we had the color, like, the color that's being summed up should probably not be in a register. It should probably be in memory, you know? Because we're doing all sorts of other shit, you know, with memory. Like, we're loading from memory all the time. And having another register to work with would be nice. I mean, it would even just like, there's only one memory write to, but memory writes are more of a thing. But not really, because we're going to segregate all our data between the threads and stuff, so I think we're okay there. We'll think about it. But anyway, this will allow us to change things around if we feel like things are not good or whatever. Okay, let's think about this again. So R9 is the current object trace index. I don't know if that's actually correct anymore. 0 sample index. We also have R8, which is what is tracking whether we're outside or inside the normal. I do not believe that's something that we will have persistent anymore. We had that before because we were keeping track of it to explicitly change it every time we sort of went inside or outside of an object, but we are determining whether we're inside or outside an object algorithmically now, so we don't need to do that. So current pixel index, that's fair. Let's say even start pixel index, you know, dot start pixel index, and it'll be a D pixels, so like 424. Yeah, I mean, definitely above a 32-bit limit is 2 billion, 2.1 billion. So we'd have to go really, really big. Yeah. So we're good. Okay, 32-bit number, that'll be. So it's a D. DD. In RD, in fact, you know. End pixel index is in RD. Where did our thing go? Where did it go? Why did it leave? Okay. Start pixel index, end pixel index. We're going to say trace index should be an RB, honestly. That's like the bounce index. I don't know why we're saying trace index and not bounce index. Is trace index actually like the object? Because that's like such a terrible name. 0 object index. Yeah, object trace index. Okay, so we should say object index instead. Oh, and the bounce indexes are 13. So we should say, yeah, object index and bounce index. Bounce index. We're going to say probably we're not going to have more than 255 objects, even once we do like a BVH and shit. I would imagine, Okay. We need to make sure we know that these are just bytes. They're just bytes, everybody. They're just bytes. Okay. So then we have sample index, bounce index, random seed. We definitely need that. So I'm going to say, I guess that's probably 32 bits. 32 bits, probably. I don't know why I have it down there. Okay, random seed is a RD. Okay. Sample index, bounce index. So we have a bounce index and an object index. Do we need a yeah, obviously we need a sample index, yeah. Do we? Yeah, of course. So let's make that RB as well. We're probably not going to go above 255 samples, I wouldn't imagine. Yeah, bounce index, we'd got sample, bounce, object. Is this in a good order? Sample, bounce, object. Yeah. Okay. And we should really put, fuck. Let's put random seed up there. That feels better. And then it says 0 if child thread. Yeah, okay, that's fair. We should have that in our. I don't know exactly what values get returned by this, so we should say we're treating it as a quad word here, but let's see what it actually, if it says what it actually is. It returns an integer. Where's our return? Return. Returns the PID associated with the namespace in which the process lives. I mean, yeah, okay. It's at 30. It says 32-bit, so let's make it. Let's do 32-bit. That seems correct. And we're gonna say PID. Process ID. No, PID is good. PID, and then that'll be an integer. Okay. Then we're gonna have. What are we going to have now? We are going to have I don't remember. How come we keep on losing our place here? I don't know why. Okay, 0 child thread, random seed, bounce next, blah, blah, blah. Okay, so we basically have that. We don't need to store whether we're on the inside or the outside. So that's it for like integer data. And then we have this shit. And for this, I think let's just stick with what we've got for now. You know? Yeah. Like we'll figure out what we want to do with this once we actually get to the algorithms, I think. This will be fun we can play around with these and make sure that the thread memory is working properly and all this stuff. So we want to say Lea. So we want to make a array of structs. Interesting, you know? If somewhere inside the definition of structure the name consisting of a single dot it found, it is replaced by the name of the label for the given instance of the structure, and this label will not be defined automatically in such case, allowing it to completely customize the definition. The following example utilizes this feature to extend the data definition directive DB with the ability to calculate the size of the defined data. Dot size. I mean, I think I don't really know. If somewhere inside the definition of structure the name consisting of a single dot is found. That's a confusing description, I find. Maybe I'm just a dumb. FASM size of struct. Hmm. Hmm. Get this cord out of my way, my god. This is excruciating. There you go. Jesus. Oh, jeez, it screws with me, though. There you go. How are we doing here? We're a little off. I guess we were always a little off, eh? Something like this. This keyboard cam really is just useless, you know? Okay, so structs. This is confusing to me. I am confused. Well, actually, I'm not that confused, but I just don't want to think about it. So we have basically a situation where struct defines the structure itself and also a size of operator, a size of thing. And so you don't, like, you can use the, you can use the offsets of the, the structure itself, like the structure definition in your loading of things. Whereas with structs, myPoint.x, myPoint plus, yeah, that makes sense, that makes sense. So you can't even like offset into a structure. Can you? I mean, if you have myPoint, yeah, I guess that's fair. You kind of need the struct. I mean, I don't even know what struct is good for. I mean, I guess it's just for defining some constant data once or something. I don't really know, to be honest. Ugh. It's so, like, in some real sense, I don't know if I want to go down this path because it's sort of turning us into a kind of a high-level language in a weird way. I mean, in a very real way. I mean, obviously not. We're just doing macros here. But, okay, what would be the cost of this? Is there any cost? Is there any real cost to this? The cost would be... My God, I need some coffee, you know. That is the truth, Ruth. That is the double truth, Ruth. I think I'm going to get some coffee. Or make some coffee, if we're being pedantic. Be back soon. Looks pretty aesthetic and shit. Oh, God. Ugh. No. Oh, we've got one view, but not concurrently speaking, huh? Average view duration 17 minutes. That's quite impressive, you know. Guess I should have Discord open on here, to be honest.
You could be vaping formaldehyde, which is used in taxidermy.
Oh, dear.
What?
Formaldehyde. Oh, dear.
What?
I knew it. Oh dear, oh dear.
What?
Aren't you an elk?
I don't know what I am.
Hey, can you take this downstairs?
Ugh. With the bugs?
No bugs.
I'm back. Thread memory. Strux. Okay. Well, let's just go with this. Ah, I see. Point. Labels are just numbers. It could be that I need the struct thing, because it could be that I think the idea actually is that if I do like an array of these things, and then each thread has their own array access, or their own array element, or whatever. Here, I might be quiet. Has their own array element. What am I trying to say? As their own array element. Oh man. I went too far. I went too far today. That's the truth. Double truth, Ruth. Structs. What do they call those things, you know? And what's your favorite kind, you know? I mean, come, everyone pop into the chat and tell me what your favorite kind of struct is. When I'm actually accessing the memory in the array element, I can't just say, oh, I have a base pointer to the particular element and I can use the names of the struct as an offset. I can't really do that, I don't think. You know? I think that I can only just, yeah. Okay, so, but anyway, here we go. So let's, then I would like to know again, let's go back here, because, not back here. There was a particular thing I was on, Phasm struct, maybe this? Yeah, okay, so, struct. Yeah, my point, and my point can be done. Yeah, okay. Plus point.x. Yeah, so, okay, gotcha. So in order to find a particular variable, we would be like offsetting from some sort of base pointer, some sort of, I mean, it's going to be our stack base pointer if we're handing it via the stack. And so, yes. And so we need a struct. So let's do that. So what's with the question mark? Right, I guess that's the idea. Like if you're, yeah. Still don't know exactly how we're gonna do a struct. I suppose we could just repeat. Yeah, we just repeat. Okay, and then we'll have the size of. Okay, so let's do struct. And can I just do end s instead of, like, I wish there weren't these, like, different ways of beginning and ending things. Like, it's so lame. Like, there's also curly braces. I can do that too. Dumb. Fucking dumb. Maybe it's not dumb. Maybe it's so that it's for portability between different assemblers and whatnot, you know? Illegal instructions, struct thread memory. Oh, okay, so struct is actually from the, like, thing. Phasm struct include. There's an include for it. There's an include for it. There's an include for it. Struct is actually a macro. Oh, that's cool, I guess, yeah. That's cool, you know? Ah, yes, gotcha. I mean, maybe I just do that, you know? You know? Like, you know? Like, maybe we don't want includes, but I mean, if the includes are always guaranteed to be there, you should use them, pretty much, you know? You should use them because that's where they come from. You know? And it's good that the language has put them out of the main spec, you know? Because it's just a namespace and all that stuff. Yeah. That being said, it's just not that much harder to do it the other way. So we might as well. Yeah, you know, if there's no problem, if there's no harm. And I don't think there is any harm here. you know? We're not going to be making our job, like, harder. The syntax for accessing, it's going to be exactly the same. If we want to move it over, it'll take 2 seconds. We will use struck. We will use struck. And then, oh, but let's go back. Oh wow, it even has like you can put arguments in, which is interesting. Yeah, I guess we should put the argument into the PID, like PID. DD PID. Excuse me. Maybe even random seed, I suppose. Yeah. Well, this won't be at runtime though, so that doesn't matter. The random seed, maybe we could though, you know, we could put that, we could define that, you know. Yeah, okay. Let's just call it seed. Let's just say seed. We know what it is, you know. Maybe we should just say start pixel and end pixel. It's quite clear what we mean by that, I think. Yeah, because we're just looking for the index and pixel index. Yeah, totally. I think easily. Should we do count for this? Maybe index is just a stupid name, you know? No, index is not a stupid name. Anyway, okay, so sample count. I think that's good. Although, right, that makes it so that our, yeah, sample index. Yeah, let's say sample index. Yeah, that's more clear anyway, especially based on my usage of it and whatnot. I gotta stop thinking about anything right now. So we're doing thread memory. We're also going to say virtual at 0. Let's even put this up here. Maybe all this stuff should be separate. Ow. Oh. What? Okay. Where did my other DuckDuckGo go? Okay, whatever. That's fine. Okay, it just opened up a tab, I suppose. Okay, so here we go. So we're gonna actually put this up here. Oh, did I bullshit it? Oh, no, I didn't. Oh, I did, though. Oh, damn it. All right, I gotta redo the definition for the struct. That is, like, so lame, dude. Okay, struck, thread, memory. Okay, let's do this. Let's put it in on the bottom here. The stuff that is most easily changed should be clustered more closely around the code. Okay, so thread memory, and it's going to be .pid. We need a seed, so we're going to do .seed, dd seed, pid rd, and then it was going to be pixel, start pixel. Start pixel, it's not a word, it's going to be a D, so yeah, we'll do RD, right? And pixel, RD, and then we'll do bounce index, well no, it'll be sample, bounce, object. Oh, we're gonna do bytes. I think that's it, possibly. I don't quite remember if that was everything or not. I feel like there might have been one more. I don't know why I think that, but I do think that, you know? Okay. Dude, it would be fun to just do some C programming, you know? Maybe we should just do some C programming. I don't know. Okay, so then we want virtual at 0. We want thread memory. Thread memory. At 0. Interesting. That is very interesting. Yeah, put it at 0 and then it makes, that's awesome. Virtual at 0. Very, very cool. That's very good. I like that. Okay, so okay. So we're doing this. We have thread memory, virtual at 0, end virtual. Maybe I can do end v, who knows? Can I? .seed dd seed. Maybe I should try the curly braces real quick. Invalid argument. I guess I'll just say 0. Do I have to, oh, what am I doing? Oh, well, that worked. Threadmemory.pid rd. Invalid argument. Okay, structures. Okay, well, interesting. I wonder why I can't do it this way, but okay, let's switch to, I don't know why also, is it, am I mistaken, like, reserve bytes, oops, should not allow you to provide a value, I would have thought, because the whole idea of it is that it's not a definition, it's just a declaration. Okay, so we're good there. So thread memory is now reasonable as a structure, and we have created one with some question marks. So that's just the struct itself. Okay, so now we want to create an actual array. So let's dupe. There should be a dupe, I think. Yeah. To make multiple copies of given values. Precede the operator and the value to duplicate, should follow. Precede the operator. Dupe db5 dupe 1 2. Interesting. It can be a chain of values, but they need to be with a parentheses. Okay. So we want to say, well, how do you even do a, stuck shell? With such definition, DB. Oh, okay, gotcha. DB. That's the struct. That's the whatever now. Okay, thread. Thread mem. Let's just say mem. Is that okay? Yeah, I like that. That's good. It's good, you guys. Okay, thread mem. So thread mems. Thread mem. Dupe. You know. Thread count, I guess. Dupe thread count, and then it should. Dupe 1, 2. Five dupe. Okay, so this precedes that. Thread count dupe, and then we'll do the actual value, which will be, can we do like, can we do the number? Oh, they like it. That's a little surprising. I guess not that surprising. It works. That's a pretty esoteric looking line. Though. Let's align this by 64. You know, let's just do it, man. Wait, times 1,000. Oh, yeah, no, we're good, we're good. Yeah, okay. This is an array. Thread local memory. Times 1,000 is alright, cool. Cool. Okay. Well, oh, it still says I'm on a break, which is not true. I am not on a break. Now I am programming a Path Tracer and x86 assembly for real. Am I centered? Am I Fenton? It won't say. Wow. It won't say. Well, that's okay. There's something, you know, good about it. What font am I using? IBM Plex Sans. That's a great font, man. A great font. Yeah. Okay. Okay, so we've done it. We've made an array. So then in order to get this array, there will now be a dot size of. I believe it will be thread mem dot size of. Which seems so cute, you know? In my opinion. Okay, hang on. I just thought of something.
message is brought to you by Apple Card. For a limited time, when you get a new Apple Card and purchase AirPods.
Apparently frames are getting dropped and things. Oh yeah, bad quality, things like this. It is what it is. Okay, Jesus Christ. Huh. What's a good syntax for that, you know?
At the resident, there's always been a huge training focus.
Yeah, hello?
Hello?
Hi.
Connor,
Yeah?
they did it.
What do you mean?
We just had to believe.
What do you mean? Oh, they did it?
It's called A Realm Beyond.
Oh my god.
There's a trailer for it.
Oh my god. Is it like all toys for Bob? It is all toys for Bob.
Yes. Yes.
Whoa.
It looks like it's probably going to be quite shitty.
I mean, it's probably like sure it'll be like a little bit more practiced than Reignited.
No, for sure. And honestly, it's a new Spyro game. Like
No, you're
this
getting a
is
new
big.
Spyro game, brother.
This is big, my dude. It's
Okay,
coming
is this just
in 2027.
Okay, it's just a cinematic trailer. That's too bad. Obviously it would be.
There's a smidgen of gameplay at the end.
Really? Is that true?
Yes.
Okay, hang
It's
on.
worth watching anyway.
Okay. Ah, fuck.
Okay, I'm gonna hang up.
All right, see ya.
Bye.
Forgot that I was on stream. Okay. Whoa, we flying? What? Oh no. They're doing like a Legend series thing or something? Oh, that's pretty fucked up. That's pretty crazy. Okay, all right. Anyway, geez, all right. That was a huge distraction to my serious work. So, okay. So what I'm thinking is there needs to be like this is like an operator. This is saying this is the definition of this symbol, or this is, or whatever. But you need another operator for actually emitting the data, and so really all of this again is just symbol manipulation. All it is symbol manipulation. And eventually, I suppose, the symbols just become, again, the symbols end up becoming literal values. Okay, the symbols end up becoming literal values. So, like, eventually, for instance, the text, like, this ends up, now this is text. It's a data buffer. It's just a data buffer now. Maybe the symbols should be text. Damn. They probably shouldn't just be text, you know? There should be numbers and text. Now, there could just be one number. It could just be decimal. You know, it could just be integer. You get the idea of what I'm saying. You know, integer, decimal, or whatever. So it'd be like, okay, so this ends up being ASCII equals. We also just say text. Type of thing, if we wanted to. No, 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 it's a symbol. Ugh. Ugh. It's just symbols. We have to remember that they're symbols. They're not data, they're symbols. But the problem is that we do need data. The symbols end up standing for data eventually. The symbols terminate into a literal. Yeah, symbols terminate into a literal. This might be too, this really might be too weird of an idea. Okay, we have this for symbols, and we have this for the this. So then these should also, these are just gonna, as it turns out, let's be honest. Text, load file name. Okay, we need to figure out how would this be equals load file name. Yeah, I mean load file name already. Should I say as text? Or say text? Or say no, the type obviously needs to be string. It's just really going against what these symbols have usually meant. Excuse me. This comma thing is interesting because you could do this infinitely. You could say like default file name. Ha! It's not a typed language because you need file name to also be able to be a literal. Arbitrary assembler. God, that looks beautiful. ADA, arbitrary data assembler, but there's already a language called ADA, which is too bad. Wonder what ADA looks like. I haven't looked at it in a while. Syntax. Cute. Well, seems like there's things going on here. All right. So, possible values for finance immersive array comments in a list in the assembler. So, this is just, it's arbitrary data here, so it can be in sort of, this is in ASCII or whatever, and that sort of thing. So I think the most, like, there would be two very beautiful ways to use this language, I think. One would be, I mean, it's similar. They're just kind of, they're the same thing, just at a different way. There's someone outside. The first would be, like, just using it to write assembly. It's like a macro language for assembly, but then also just using it as a macro language for C would also be kind of dope. Be kind of, just like awesome. Could it work as its own language in reality? Like if you created Obviously, you would need to just build these things out of assembly. Really, yeah, this is like a meta language. Which is pretty cool, I think. You know, it does kind of allow you actually to be operating system independent, you know, in a way. Like as a language, not necessarily as like a, like, not the programs in it. That's, you know, that they would be very unportable, or they'd be just as portable as whatever your output stuff is. I don't have my tuned guitar. I have my untuned guitar. My untuned guitar, untuned. Oh, is that good? It's got warmth, I think. So bad at that. It's better than it was before. It's better than it was before. put coffee on my sleeve. It was an accident, ma'am. Okay, so where are we? So we've got this, no offensive definition. I think we get the idea. Okay. You know, it does feel like maybe we shouldn't allow that. Yeah, because the symbol, symbols terminate in... Maybe it should just be put, you know, put... You know, maybe we do like that. You know, we put it into braces. Or that, you know? You know? I mean, this could be the tilde, you know, that would be kind of crazy, you know, that would be kind of cool. Do we need a symbol, you know, to say what it is? You know, yeah, I think so. I think we kind of do. Yeah, well, if like a symbol ever appears by itself, all that means is to, you know, make that be the thing. I mean, the thing is, in a way, something like that. All right. Okay, so anyway, Source load file name. Okay, so okay, so it is interesting. We kind of do need like load is awkward because it is a word, and we have basically no words. You know, maybe it ought to be a like this, you know. That's kind of awkward, you know. Maybe at, you know, something like this. I don't know, you know. Some syntax for reading files. We'll see how many different things actually happen in this situation, and just, you know, and, yeah, you get the idea. We still need to figure out, yeah, how do functions work? So how do structures work? So yeah, you know, the thing following the at sign needs to be a thing. We should actually, honestly, let's Bacchus Now form this. Bacchus Now form. So we've got this, and then that. It goes, okay, all right. So let's say expression exper. I mean, are they even expers? Are there even these things called expers? We're going to say expressions are either a let's embed this as well. Is going to be either a symbol def, let's say symdef, I don't know, or a I guess symbol resolution, right? A symbol resolution. It's either a symbol definition or a symbol resolution. Symbol. and then colon, and then it's going to be a resolution. Interesting. A resolution is interesting. So it can be either a resolution. Do I need to like how do I like do, I don't know why why I actually care that much about whether I'm doing this correctly. But yeah, it would be parentheses. So it would be either parentheses resolution or such a cool looking. I love the way Bacchus Now Reform looks. It'd be cool to make a language that looks like that. It's just a total waste of effort, obviously. Okay, for the programmer, yeah, whatever. Okay, so anyway, so this can either be, so a definition can either be a symbol, or a resolution. Let's say symbol or resolution, because it can either be a symbol, another symbol, or a resolution. This is in some sense the wrong way to, like, we really need to define definition and resolution, I think. Well, that's what we're doing. But, resolution is an important definition. Resolution. They're all expressions. Just, yeah, that's the way that programming languages work. Let's what is the C BNF form for C? Function definition or a declaration. Gotcha. Either a function definition or a declaration. That's crazy. I guess that makes sense. Declaration, Declaration is a great word. Yeah, it's either a definition or a resolution. So a resolution is a simple one, the simpler one, in a sense, which is to say, what can be a definition or a resolution. So it can either be a literal, oh, my computer. Oh, my computer. It is going to turn off. Maze, my computer is going to turn off. Okay, where was I? This is fair. I was going to do it this way, which is very cool, I think. I think that's pretty cool, yeah. Okay. Okay, so, where are we? So, integer, decimal, or string, you know, something like that. Alright, I'm going to close this computer now. So now I don't know who's watching me. I'm probably going to stop streaming soon anyway. Okay, so we got all these. It can be all of those things. A resolution can either be a literal, or it can be another resolution. That's really the thing. Right? It's a little bit more complicated than that because, of course, there's this question mark operator and all those things. It's a lot more complicated than that, but that's kind of the idea. And that would be the first thing to, like, do. There's this whole thing about namespaces as well. Yeah, so it's not just a symbol. A symbol doesn't have to just be a symbol. Oh, no, well, yes, interesting. Yes, right. So is a symbol can be built up of a number of atomic operations. That's one thing. So, like, true. Okay, so that's interesting. This thing here is special. It's loading data. So it's not, it makes sense not to use a, it makes sense not to use a thing for it. So, how would you do this? You could just do that, you know? And of course, we can always do this as well. We can always say file name. let's actually make sure we've got YouTube. YouTube, so that I can see if someone's watching me. I suppose if someone was watching me, that would be just horrible. There is nobody watching me. We're killing it, boys. We're killing it. Okay, so so we've got this. So that works. Load. And load would end up being built out of, like, load would be a standard library function, I guess, but that's not, doesn't seem good at all, no. It can't look like just a function call, like, so it can't be like a scope thing. How do scopes and the functionality inside the scopes work? Resolutions are expressions. A resolution is made out of a expression. So it's just the same thing as an expression. A resolution is the same thing as an expression. Yeah. Okay. So an expression can also contain where's Bacchus now? The Bacchus now form. How do you do the list? Is a list a redundant thing? It's like statements, I don't know. Alright, let's do extended Bacchus Naur form. Ah, okay. Curly braces. You know? Okay, so curly braces. Some number of statements. Yeah, so I guess the thing that we're not able to do here is like return things. Okay. Within a scope, what you are outputting is the return. That could be pretty wacky. Could be pretty cool. I'll be back. Don't run with knives, people. Don't run with knives. I'm telling you guys. You've got to be careful. You've got to be careful with knives. Not me. I am a sort of Ubermensch. And I can be relatively, I would say, safe and effective running very fast with a knife. You know, I can go a lot faster than you guys when I have a knife because I have the poise. I have the poise, you know, and I got the boys, you know. I got the poise and I got the boys. And that's all you need. That's what they tried to take away from us. That's what they're always trying to take away from us. So, we sure are back as nowering. Last bit does not taste very good. Yeah, it can be a scope. Because the scope, the output of the scope, is then equals the expression. At this point, you know, we could also put things like file loads. But, you know, again, I suppose it just makes sense to argue that, like, yeah, no, but loads are atomic operations here, dude. You know, I don't think I know that number. Okay, load is part of literal, I think. type. Right. There probably shouldn't be type enforced at the beginning of a literal. Obviously. Right? And load just terminates into one of the others. Okay. This is in math, you know. That's probably relatively bad. Ugh. God damn. Excuse me. I think we get the idea. Okay. All right. So load string, and then so that's a load. Load, and you'll bet your gas. Alright, I'm just gonna call this for now. I don't know. It's kind of interesting thoughts, but might not go anywhere. I'm gonna stop streaming.